This is an introduction to fluids in physics, and the next 5 videos will also be on fluids. However, fluids usually requires a lot of calculus, but I don't cover any calculus on this channel, so we'll be looking at it from a conceptual lens. We'll still do math because there's still a lot you can do with algebra. Just know that if you came here for calculus, there's no calculus. So what's a fluid? A fluid in physics is defined as anything that flows. So this includes both liquids and gases. So air and water are both fluids. We don't split them up because these things both flow. For example, if you pour water into a cup, it flows. If you open a balloon and air rushes out, it's flowing. The same laws apply. The particles both move freely and the forces spread through them. Here's a very important topic that's everywhere in fluids. It's density. Density tells you how tightly packed the stuff inside something is. It's not about weight. It's about how much mass fits in each cubic meter. For example, if you had a shoebox that's this big, you could either fill it with feathers, so it's pretty light, or you could fill it with bricks. If you fill it with bricks, it's more dense, but it's the same size. And here's a misconception about density. People say heavier when they actually mean denser. For example, would you say iron is heavier than wood? It's actually not always true, because you might have a tiny iron nail and a giant wooden log. This is not heavier than this log, but iron is denser. If you had the same amount of iron and the same size of wood, the iron would be heavier, taking up the same space. That's density. And density has an equation. This equation is P equals mass over volume. This isn't actually P. This is a special Greek symbol, but it looks like P, so I'll just call it P to make it straightforward. This is mass per unit of volume. For example, if you have a beach ball and you also have a bowling ball, they're the same size. The density depends on how much mass fits in each unit of volume. And this bowling ball is denser in this example because the bowling ball fits more mass inside every cubic centimeter. There's a variation of this formula, and it's pretty useful. It's mass equals density times volume. And here's one last concept. It's very useful when you look at how things float later on. And it's called specific gravity. Specific gravity is equal to the density of your substance divided by the density of water. What does this do and what is this for? Fresh water usually has a density of 1,000 kilograms per meter cubed. And by the way, this is the standard units that you'll see for density. That means if your specific gravity value is bigger than 1, then your object will sink. If your specific gravity comes out smaller than 1, then your object will float because it's less dense than water. It's just a comparison tool. This isn't some new math or a new formula. This makes studying 10 times easier. Go download the free cheat sheet in the description, and I'll include a free surprise worksheet from my premium study kit to help you understand this topic.